Hello friends, in the previous video we had gone through the conditions of line where first the line was perpendicular to the horizontal plane and parallel to the vertical plane. Condition number 2 where the line was perpendicular to the vertical plane and parallel to the horizontal plane. Condition 3 where the line was parallel to both vertical plane and to horizontal plane. Now we are going to introduce angle into this. In this first condition, we have line AB which is parallel to the vertical plane, but it is inclined at an angle of 30 degree from the horizontal plane. So this dash dot line is the horizontal line which is parallel to the horizontal plane. From there it is at 30 degree angle where we have placed line AB. We will try and understand how this will get projected on the vertical plane and the horizontal plane. So our line is at an angle of 30 degree from the horizontal plane. This condition will get projected on the vertical plane, therefore it will be visible on the vertical plane. What I would do is make a rough line in out here, take a point and draw a line at 30 degree. On this line of 30 degree, I will mark 20 mm dimension, which is from here to here, and this will identify my line A, B. What was done? I drew one reference line. I took a point randomly on this line. From there, I made another line at 30 degree angle. This was identified as point A. From here, I took a distance of 20 mm, identified point B and joined the two, and I got the front view of the line AB in my vertical plane. We have a line of 20 mm length which is parallel to the vertical plane and it is 10 mm away from the vertical plane. This line is inclined to the horizontal plane at an angle of 30 degree and the point A is 10 mm above the horizontal plane. What did I do? I first took a reference line in the vertical plane because the true length of the line is visible only in the front elevation. I took a reference line at a distance of 10 mm from the XY line. I drew this reference line. I identified a point, random point A on this line. I drew a line, reference line at an angle of 30 degree. Point A was identified. On this reference line, I took a distance of 20 mm, identified point B. When I joined these two, line AB was achieved of a length 20 mm. I took down projection from point A down to the horizontal plane. I took down projection from point B down to the horizontal plane. This line is 10 mm away from the vertical plane. So from the XY line, I took a 10 mm distance, drew this reference line. Wherever this projection cut the reference line, it gave me point A. Wherever this projection cut the reference line, it gave me point B. This is the front view. This is the top view. The difference between the line in front view and the top view is that line AB is parallel to vertical plane. Therefore, we are seeing the true length of this line. Whereas line AB in plan is an inclined line, which means it is visible like this, and since now it has taken an angle, the length visible is shorter. If I overlap the two, then point AB would overlap like in the previous video. So we will not see the true length in the top view, we will see the true length only in the elevation. Therefore, the dimension of the line will be given only in the front view in this case. Now we will take the second case. In this case, in the second case, we have a line which is parallel to the horizontal plane and at an angle of 30 degree to the vertical plane. Point A of the line is at a distance of 10 mm away from the vertical plane and the line is 20 mm away from the horizontal plane. So the conditions given to us is the length of the line, the angle that it has with the vertical plane, the distance at which the point A is located from vertical point, and the distance at which the line is away from the horizontal plane. In this case, we had started from the front view. In this case, we are going to start on the horizontal view. So we have taken a reference line which is at a distance of 10 mm from the vertical plane. This will identify our point A. At a random point, I took another reference line which is at an angle of 30 degree from this reference line. On this 30 degree line, I took from point A a distance of 20 mm and identified point B, and joining these two I got the line in the top view. The line is parallel to the horizontal plane and at a distance of 20 mm. So I took at the distance of 20 mm, I made this reference line. Wherever the projection from point A cut the line, I identified it as point A, and wherever the projection from point B and cut the reference line, I identified that as point B. And this gave me line AB. Like this, where the true dimension was visible in the front view, in this case, the true dimension will be visible in the top view. And this is the condition of front view and top view of the second case. In case 1, the line was parallel to the vertical plane but at an angle to the horizontal plane. In case 2, the line is parallel to the horizontal plane but at an angle to the vertical plane. Wherever the true dimension is visible, that is where you will give the dimension of the line, not in the other case. This video takes care of the condition where the line is at an angle to one of the planes but parallel to the other plane.